Welcome to a new video in my home automation series, and today I'm just going to talk about a little bit more Grafana, InfluxDB and Node-RED kind of stuff. And what I'm going to do today is talk about finally integrating the Shelly it's the Shelly 3EM into the whole sort of home automation setup. I mean, it's not really automation. I mean, the way I was using the EM3, not 3EM, EM3. The 3EM up until now it was connected in my main breaker box, which is pretty much looking at the incoming three phases to my house. And this was the device that helped me to wire up the three different inverters into the three different phases. Because when we set it up in the summer, I was just looking at the 3EM, just making sure that each of the phases are generating power. That was the only way for me to tell that they are on the separate phases, because they are each in separate parts of the home. So we somehow needed to locate the phases, which phases they are on. And I mean, for the last 6 months it was just sitting there, and I was occasionally would just pull up the Shelly app and looked at the consumption, but I wasn't doing anything else. And after I finished the my dashboard on the three inverters, I said finally now I have a final, Grafana. And somebody said, never say final. And he was actually right, because a couple of, probably about a month or a month and a half has passed, and I'm making changes to it. So I thought it would be nice, besides, whenever I want to see the solar generation, I also want to see the total, consumption and the generation for the entire house. So I thought, okay, let's just put the Shelly 3EM, configure it to MQTT, put the whole data into InfluxDB, and then just build a new, not a new dashboard, but a new widget in the solar dashboard, which is going to show this information. And this is what I'm going to talk about now. So just quickly going to talk about the how I reconfigure the Shelly 3EM, how it is sending the data over MQTT, how I'm processing it in Node-RED, and the whole InfluxDB and the Grafana part. So the Shelly 3EM is, I made a separate video about, but it's basically like a three-phase energy monitoring device, which uses current clamps to clamp on the three phases. And you can just, for example, I'm using to monitor the three phases that are coming into the house, and it's able to measure consumption in both directions. So it can tell me when I'm generating more power that I'm using, or the other way around. So at the moment it's 10 p.m. so obviously the sun is not out, and so I'm just using this much electricity in the three phases. Sometimes it is shocking to see how much power I'm using, even though I'm just like, the TV is running, the kids are already at sleep, and still, I guess it's all the pumps and things are going. So it's 300 watts here. So 700 watts. Okay, so that's it. So first, when I set up the Shelly 3EM, I was just using the standard cloud configuration, so all the data was going into the cloud. So first thing I've done, I always forget where to set it. Oh, it's under cloud. No, it's not under cloud. It's under the advanced settings. That I enabled MQTT, and I specified my user and their password and the IP of my MQTT server. And I take this one as well, because by default the topic is going to be Shelly 3EM3, and then it's going to be an ID, which is, I guess it's a part of the MAC address, which would be useful if you have multiple, but I just have one, so I just set it to Shelly 3EM. And I have these settings, and basically I saved it. And because this is like a first generation Shelly, once I do this, the cloud connection is not available. But I wanted to do that. So once the MQTT connection was done, then in the MQTT Explorer I could see that I have a new Shelly's topic, and under it I have the Shelly 3EM. And it has a relay as well, which I'm not using for anything. But what I really am interested about is this e-meter subtopic, and within that there are three different topics, subtopics, 0, 1 and 2, which are the three phases, and for each of them you are getting all these data. So there is a power, which is the actual power in watts, You have the power factor, the current, the voltage, the total. So this is the total consumption since the unit was installed or since it was reset, because it's possible to reset this value. And you have also total return, so it measures the return power separately. So it either increases the total or the total return, depending on the direction. You have an energy and the returned energy. So this is pretty much the same as the total, but this is in watt minutes. So that's basically the consumption in 1 minute. Yeah. I'm not sure if this is total returned, why this is saying returned energy, not energy returned, but anyway. So this is watt hours, but this is watt minutes. So here on this phase, I have used 333 watt minutes, which is, divided by 60, that would be on watt hours. So that number, actually I haven't checked whether that number changes by every minute or it changes all the time, but I'm guessing it changes every minute. And my strategy was that my solar data, I'm capturing the solar data every single minute. So I thought I'm just going to capture this information as well, and at least then the energy minute or this energy value would only show me the value for the last minute if I'm also capturing it every single minute. And when you see the graph, I think it works fine. And then the same for the second and the third phase. So what do I do with this information in in Node-RED? I usually prefer a single topic with a lot of values in it because it's much easier to process it in Node-RED. But I'm guessing if you're using anything else like a Home Assistant, then having multiple topics with a single value is probably more useful. So what I decided to use is, I've created all these MQTT in nodes for all the values in all of the 3 phases, and I'm just putting into a global variable. So, and actually I can show you the global variable here. So if I go context and global, it's going to be loads, and there is house. I'm calling it house. So it has phase 0, phase 1, and phase 2, and in each I have the same values: power factor, current, voltage, total, yeah. And I have 2 more, which is the power max and the power min, because I wanted to capture what is the maximum power within that minute and the minimum power within that minute. And I just realized that I have made a mistake, because then the max power should use the no. So obviously this looks at the power, and this power can be either a positive or negative value. So yeah, we are good. So when the whole Node-RED starts, then I create these skeleton object, which is phase 1, phase 2, and phase 0, phase 1, phase 2. And then later on, whenever a value comes through in the MQTT node, I just use a very simple change node. So I just push it into global.house.phase0.power, and then the message.payload converted to a number goes into that value, because that's the other thing I don't like about a single topic, multiple topic with a single value, is that MQTT treats everything as string. At least if you send it in JSON, it comes through as a correct value. So you always have to convert it. And I just use the the JSON expression, just $number, and then whatever string gets converted to a number. And it works with float and integers as well. So it all gets stored, and obviously in phase 1 it goes to the phase 1 variables, and then in phase 2 it goes to the phase 2 variables. And this small function node, it just calculates the maximum and the minimum values. So as you can see, it looks at what is the maximum and the minimum value, and if it doesn't exist yet because it just got reset, then it sets the current value to either maximum or minimum. And yeah, and of course it saves the value. So that's pretty much it. And I have 3 of these for each of the phases. So this would update this global variable, and I think, you can probably tell the frequency here, but it looks like that we are getting readings every sort of like 10 seconds, I think. I'm not really sure. Or maybe look at the maybe you can look at the history. Ooh, how do you? Okay. So yeah, something like 10 seconds. A little bit all over the place. Oh no, even less. Yeah, nah, the difference was 21 seconds, 30 seconds. I guess it looks at changes as well, so if there is not an awful lot of change, then it wouldn't send an update. Maybe there is a threshold how it sends it, but I'm not sure if I can configure that one. So that's probably something built into the firmware. And then, as I said, I want to capture this information every single minute. So I have an inject node here, which fires every single minute, and it gets the value from the global variable and it puts into the payload. And then I thought maybe what happens if the Shelly dies and there is no change in the global variable. I don't want to just record all the same values, so I just have this very simple filter node. I'm starting to use this more and more nowadays, which basically just blocks the message unless the value changes. And then I convert it to a flux value. So I decided that I'm going to use my sensor measurement, which if you remember, in the sensor measurement I have a device, like a name of a device, and then in that I can have as many values as I want. So I decided that as I said, the measurement is going to be sensors, and the device is going to be called house underscore phase 0 or house underscore phase 1 or phase 2. And then the payload is going to be all the values that you can see here. So every single attribute here goes into the fields. So I create these free line protocol records for InfluxDB, and then I zero out all the max and the min. So those max and the min would again contain the maximum and the minimum for that minute. And then I send the value, and then it goes to an Influx inject node, which is somewhere here. And yeah, it's here. Sometimes this navigation doesn't work perfectly. Anyway, I think I mentioned this before. So it goes to my Node-RED bucket, and then the information will get saved. So, and let me check if there is anything else in Node-RED, but I think there is nothing else. So, come on, please move. Yeah, there is nothing else in Node-RED. So now we can go to InfluxDB first. So Node-RED and the sensors, and the device is, as you can see, house phase 1, phase 2, and let's see, we look at the power. Yeah, you can see the power, and if I go to the last 24 hours, and that's how it looks like in the last 24 hours. And of course, I mean, the reason I'm doing this power max min, because this actual power is going to be a snapshot for that particular minute, so that's never going to be as accurate as let's say looking at the energy, which is going to be the watt minute consumption. And I don't think I would need, the resolution anyway. So yeah, I'm storing all these values, but to be honest, I think in most cases I'm just going to look at the energy and the returned underscore energy, because yeah, I mean, current is pretty much power as well. Voltage, I don't think it changes that much. Power factor, probably not. I mean, yeah, I don't really care about power factor. I'm not a commercial user. So this is all what it goes to InfluxDB, and let's look at how the Grafana looks like. So if we just look at the graph, you can see that I wanted to replicate the same graph that I've seen on Shelly. So I wanted to have an area which is, well, basically everything which is above 0 shows me that I'm consuming more than I'm generating, and then if it dips below 0, then well, the sun is out and I'm generating more energy that I use. So as you can see here, I'm not really sure what happened in the morning. What are these big spikes? Because I mean, I can think about maybe the microwave for the breakfast, but I don't think we would use the I mean, the kettle. Probably this could be kettle. How many minutes? Yeah, we are talking about like 5 minutes, and I'm not sure about this one because we usually go at this time. But maybe this is when I think probably this was a washing machine that started in the morning. And then I remembered I had lunch this time, and then my wife was coming home a little bit later, and then she had lunch this time. So this was 2 peaks from the microwave, and this is probably again like an oven or something for the breakfast. No, it was earlier than that. There was something else. Maybe that was the dishwasher. So you can pretty much tell, like, you know, what is happening in your house, especially if you figured out you know, which device is connected to which phases. And of course we had a fairly decent sun during the day, so I was pretty much generating excess electricity throughout the day, all the way until yeah, I think it started to become cloudy in the afternoon. We even had a really quick snow shower, which was really weird. But then the sun came out again, and then it was sunny again, so it was a mixed match of you know, some strange winter weather. Okay, enough talk about that. Let's look at how this graph looks like. So, okay. I want to look at the query first, how I make this bigger. Oh, I don't know. Well, actually, pretty much everything is shown here. So I'm getting the data from the bucket Node-RED, and of course I'm using the time scale, which is up here, and I want the measurement sensors, and I'm all interested about the device phase 0, phase 1, and phase 2, and I only need the field energy and returned energy, so I don't really need anything else. So I just restricted the filter to these values. And then I will come back to the usual pivot. And the reason I'm using pivot because I don't want the energy and the returned energy in 2 separate fields. I actually want to combine them together. But in order to combine them together, you need to pivot because that's the only way you can use the map function. So again, if I go back to the data explorer, so if I paste this in, and if I look at the table view, then you can see, oh, let me just pick something smaller so it goes faster. Okay, so you can see that with this you are getting a table stream with 6 values because you want energy and the energy returned, and with under 3 different devices. So that's 6 tables altogether. And I want to add the, what is it? The energy and the returned energy together. So this is why I needed to create a pivot first. So once you do the pivot, and I think this is going to be, I mean, I will be using this pivot so much. And this is the easiest way to use the pivot is the row key. So the rows that you want to create, obviously you want to create them by time. And this was one other reason I wanted to combine all the data into a global variable and then flush them out to InfluxDB at the same time, because then for each of the phases, for each of the, you know, the power return, sorry, the energy, returned energy, voltage, all of them would get the same timestamp. That was the main key, because that would make you know, creating all this calculation much easier. Because if you have them in different you know, timestamps, for example, you wouldn't be able to do the pivot because, well, the time is going to be different. So the row key is the time, and the column keys, I want my fields, so returned and returned energy, to appear as columns. So this is why they are in the column key. And the value columns, well, that's the value. So it's the value that should go into the cell. So if you execute this, you will notice that we still have 3 tables because the devices are different, but now we have an energy and the returned energy column. So we have transformed the values, and we still have the, you know, the device here and the measurement. So now what I need is, I need mapping, because I want to add the energy and the energy return, and actually both of them are positive values, so I need to take I need to extract returned energy from the energy. So this is when you are generating, you are getting negative values as well. So if I do that, I have an additional column, which is the new value. So the value equals energy minus energy return, and you don't see negative values here because I just do past 1 hour. So if I do past, yeah, now you can see negative values. So this is when I was generating 1 kilowatts on this phase. Oh, actually that's 1 kilowatt a minute. Okay, so this is looking good. And finally, I just drop some columns that I don't need. I think this last step is not necessary, well, it's not exactly necessary, but I guess by dropping columns, it helps to transfer less data between InfluxDB and Grafana. So probably it's just going to make your reporting faster. So for example, here, I don't need a start and a stop. I don't need a measurement as well. I don't need the energy and the energy return because I'm just going to use the underscore value anyway. So I do this and I just have much less data to look at. I think I probably should have or could have deleted measurement as well, but I definitely need a device. So now we have a table stream with 3 different tables, and this is something that Grafana can understand. And here what I have done on the graph is, let me show you 2 things. So if you noticed, I didn't do a an aggregation window, which is, that was my decision that I want to see every single data point. I usually only look at a specific day, so I'm not going to look at generation, especially in this granularity, for an entire month or a week. For that, this dashboard is going to be honest, pretty much useless. So for that, I would need a separate aggregated dashboard. So there is no, aggregation window here, but you could add an aggregation window because, these values are nicely formatted now. So 2 things that I've done here. First of all, what I usually do is I created some overrides. So mainly so I can have nice text label here, like phase A, phase B, and phase C. So there is an override and like a display name, and I have also created the unit. So this is watt minute. So this is why we are seeing these watt minute values here on the scale. And I have done one more thing. So I created these values here in the thresholds. So the base is 0, and anything which is more than, the base is green, and anything which is more than 0 is red, which is not being used in a graph because the graph just uses some standard colors. So these series colors just got automatically assigned by Grafana. So the green, yellow, and blue. But what I did here, so you can see the classic palette. But what I did here, I need to find that one because this was the first time I was using this. Yeah, finally I found it. So this is the threshold mode, and you can see here that normally it is off, so you don't have any like regions, but you can just set it to show them as lines. And because I have a threshold here which is set to 0 and it's colored red, now I have a red line at 0, which looks good, but I want a little bit more. So you can also do the regions. So the region for these thresholds get filled with the respective colors, or you can also do lines and regions. So you still have the region here, and then basically the 0 line. So now this graph tells me that if I'm in the red, this is the bad because I'm using more energy than I generate, and if I'm generating more energy than I use, then I'm in the green zone. So I guess it makes sense. And of course, these, the lines would wiggle with their respective colors. So this is something that I haven't used before, and that's something new. And well, this is such a good and easy feature. And you can just play around with your lines and the colors using these threshold values. And of course, you can have multiple of these. So if I want another one, like above, I don't know, 1000 milliwatt hours, I can just create another threshold with another color, and it would have a different line and a different band associated with, whatever you set here. So I think this is quite a neat feature, and it looks pretty good with this type of graph. So this is what I have done, and I just feel that this type of graph goes very well together with generation, because when you are looking at your generation, you can just immediately compare it with your consumption. So now what I can see here is that I'm working from home, and my wife is also here at home at the moment. So obviously we are not using an awful lot when we are working, just a couple of laptops running and lights and that sort of stuff. So it's interesting to see how the generation basically mimics here, because there is almost nothing used, or while there is a constant consumption used. So the way the graph looks like in a generation is pretty much the same when it is compared to the overall consumption versus generation. So I think that will be all for today. If you are interested in this flow, I'm going to publish the Node-RED flow for it, and I think I haven't done it yet, but I think I can somehow export the Grafana settings in JSON as well. I don't know if I can do this with a single panel, but maybe, oh yeah, maybe I can do share or something. I would need to investigate. I haven't done it before. But panel JSON. So yeah, I can just save the panel JSON and I can just upload it. So if you're interested in that, you can find the link in the video description. But I think that will be all for today. Thanks for watching, and hopefully see you in the next video.